There's a hidden assumption that explains why the smartest thinkers in technology are so enthusiastic about AI right now. This is the thing that you should understand if you want to understand what's happening in artificial intelligence today. Let's look at 5 quotes from technology leaders that tell the story. So the hope here is that in this video, you're going to understand something that is super important to technology today, and whether that basic belief is true or not. Okay, first, let's lay out the assumption. It's this. Because artificial intelligence makes people faster and better in coding, it should also make scientists better and faster in science. In other words, AI is so helpful in coding that it should also be so helpful in creating scientific breakthroughs. That is such a big deal because when we talk about breakthroughs, the biggest potential breakthroughs are in science, in medical science, and in engineering science. We're talking about curing disease, reversing aging, or in engineering, creating the tools that'll actually really get us into space and even beyond the solar system. If we can become super geniuses in science, like we basically are now in software, the future is unlocked. And that is the progress that the technology world wants to keep going after. So how does that connect to what's happening right now? Let's get into the quotes. Quote number 1, AGI is literally here. That quote comes from Gary Tan, who's the president of Y Combinator, from a recent podcast where the Y Combinator team talk about Claude Code and OpenClaw. AGI means artificial general intelligence, and that is where AI could have human or greater intelligence across a variety of domains and essentially work independently in those domains. So when Gary said AGI is here, he was talking about Claude Code. So Claude Code is a coding tool, probably the leading coding tool. You give it coding jobs to complete, and then it goes and it executes those jobs across your files, acting mostly independently, delivering really high quality code that you can just check, or maybe even don't check, you just accept. And all of a sudden, you're building software almost at a speed that was unimaginable before. I started using Claude Code and other tools like it, for example, another tool called Cursor, a while ago. And I started with very simple tasks. For example, one day, the first time I ever used them, I had to build a series of alerts and confirmation boxes in an app that I was building. Decided to give it to Cursor to see what it could do. Probably something that would have taken me 45 minutes, Cursor was able to do in 1 or 2 minutes. Pretty exciting. But here is the key thing. Once I started realizing that it could help me go so much faster, I also got much more ambitious in the kinds of code that I wanted to execute. So pretty soon, we weren't just talking about confirmation boxes and alerts in an app. We were talking about entirely new types of apps that I never would have even tried to build before had I not had a team with me. And pretty soon, I was building these extremely ambitious projects that, again, I probably wouldn't have tried before. But even if I had tried them, maybe I would have given myself a week to do what I was doing with Cursor and now Claude Code in about an hour. It is truly a too good to be true level of product. It is extraordinary. That is the kind of thing that Gary Tan is referring to when he says AGI is literally here. So I don't think he's right with respect to AGI. AGI is really a term that's used for AI being able to execute tasks across a variety of domains, not just something more specific like coding. But the underlying point is real. The power is so extraordinary, and that leads us to quote number 2. An Anthropic engineer currently averages 1,000 times more productivity than a Google engineer at Google's peak. Okay, this was also from the Y Combinator podcast, a separate podcast where they were interviewing the person who created Claude Code, and they were talking about how at Anthropic, they use Claude Code, and that is the kind of power that they're seeing. 1000x what a great engineer at Google would have been able to do at Google's peak. This is the key thing to understand. Tools like Claude Code and Cursor, they don't just make you faster, they make you much better at the tasks that you want to complete. They give you an ability to be much more ambitious than you probably ever would have been able to be before. And that leads us to quote number 3. If you have the data and you have enough GPUs, you can solve damn near anything. That was a quote from Ben Horowitz on the podcast Invest Like the Best with Patrick O'Shaughnessy. Ben Horowitz is one of the co-founders of Andreessen Horowitz, one of the leading VC firms in the world. And his point was, just like what we're seeing in Claude Code, with AI, the tools seem to be so powerful that anything is on the table to solve. Any breakthrough should now be possible. That's the idea, at least. Okay, so now we have the basis of the first part of that assumption, that AI tools make coders faster and better. Now let's connect it to the second part of the assumption, the science part. And that leads us to quote number 4, which is this. I think we will have some scientific breakthroughs with AI that positively break through into the mainstream press and awareness. So that's a quote from Brett Taylor on the Cheeky Pint podcast, which is the podcast that Stripe produces. Brett Taylor is the CEO of Sierra, which is one of the leading AI companies today for enterprise. So it provides enterprises AI agents to complete a lot of customer service related tasks. And it's kind of exploded. Its revenues have gone off through the roof. And on that podcast, Brett was asked, well, what is your biggest prediction for AI in the next year? And he talked about science. And let's round it out with quote number 5, which is this. Just in 12 months, software engineering has fundamentally changed. Over the next 12 months, we're going to see profound changes in the way that science is done. That is from the OpenAI podcast, where they're interviewing the team that is leading science at OpenAI. And again, they are talking from that assumption, which is, look what AI has done for coding. Gosh, we really think it's possible to do something similar in science, and wouldn't that be so exciting? So we've got the 5 quotes, we've got that assumption. Is it right? Well, there are some awesome examples already. For example, Open Evidence is a spot where you can use AI to query scientific research, so you can do your scientific research in a much more efficient way. And AI has done some other impressive stuff in science. So researchers at Google's DeepMind developed AlphaFold. That's an AI system that became super good at predicting the 3D structure of proteins based on the amino acid sequence of those proteins. Basically, these are the kinds of breakthroughs that folks have been looking for decades that AI was able to achieve. So that's very exciting. But there is no Claude Code for science. Not really. That equivalent doesn't exist right now. And there are a few reasons why. So in coding, the environment is really self-contained. It's all right there in your environment. Everything that you need to work with is right there on your computer in your IDE environment. And Claude Code can work with that, or Cursor can work with that, or other tools can work with that. Whereas in science, there are just more things in play, right? There's the data, there's the research, there's the analysis, there's your hypothesis. A lot of that can happen on your computer. But eventually, you're going to have to go off your computer, right? You're going to have to go into the lab. You're going to have to go potentially interacting with live humans or animals to really see the results and whether those results work or not the way you want to. That's a dynamic that's inescapable in the scientific environment, whereas in the software environment isn't so much the case. And there's another issue too. Coding is perfectly suited for the AI models that we have right now, for their training and how they work. First, the internet is super rich with information about coding. It's all there on the internet, basically, right? In tutorials, in GitHub repos that lay these things out really well, in Stack Overflow forums. This is what the models have been able to be trained on in the coding environment. The information is all there, and it's ready for them to use. Second, coding is literally the language of computers. Precise syntax, rules that are executable, and you can literally see immediately if your code works or not by running it and seeing if there are errors. Now let's compare that to science, especially medical science. First, there is a lot of medical research online, but it is not as open and accessible as coding information is online. And second, in science, it's not as easy, especially not as easy for a computer, to understand whether the answers that are being produced are correct versus the way it is in coding, where you can just execute the code and see what happens. So science is not the same as coding, but that doesn't mean the story is done. So for example, Amazon, of course, started with books in the 1990s because selling books was perfectly suited to its business model and the development of the early days of its business. Kind of like coding is perfectly suited to the development and the relatively early days of AI. But Amazon was able to expand as it got more sophisticated, and now, of course, it can cover many, many, many products. And potentially the same can be said for AI with respect to topics beyond coding. Medical science and engineering are less idealized for AI development than coding, but there is still a lot of area of overlap, and there is still meaningful hope that we can make serious breakthroughs. So this is the big thing to watch in the technology world over the next 12, 18 months. Will AI be able to produce meaningful scientific breakthroughs in medicine and or in engineering that kind of cut through the noise and are clear examples that the promise of AI can be fulfilled outside of the coding environment? And here's the thing, I feel that optimism too. I had that thought myself the first time I really saw the power of these AI-based coding tools like Cursor and Claude Code. When I started going from using these tools to create alerts and dialog boxes in my code and in my apps to bigger and bigger apps and more ambitious things that I never would have been able to do on my own. That's when I started thinking, wait, if these tools can help me as a programmer, what can they do for scientists? What can they do for engineers? What could this mean for curing disease, for increasing the length of life, for going into space? This is the exciting stuff. This is why people are optimistic. This is the promise. Let's see if it can be fulfilled. Maybe you can be one of the people that helps it become fulfilled.